All right, guys, welcome. This is 3.1 functions. So we are going to learn what a function is today. We will evaluate functions. We will simplify functions. We will find the domain of functions, all that fun stuff. So let's get started on what a function is. So definition, a function is a relation in which each element of the domain corresponds to one and only one element of the range. To put it simply, the first components are all unique. So what this means in English is that for the domain, all the x values in the domain belong to one and only one y value in the range. So look at the little blobs below. They show the pictures of what a function is and what is not a function. The first blob represents a function. So here's our domain x, and we see that our one x value goes to one y value, and then we see that another x value goes to one y value, and then another x value goes to one y value, and it's okay if multiple x values go to the same y value, because it still falls under the definition of a function. One x value has one y value, and then another x value goes to a y value. So this is the definition of a function. Every x has one y, right? Every x has one y and only one y. What is not a definition of a function is, of course, the second blob. Well, let's check it out. A goes to 1. Good. B goes to 1. Perfect. So again, multiple x values can share the same y value. And then C goes to 2 and C goes to 3. That is a no-no, because now we are saying one x value has two y values, and that is not the definition of a function. The definition of a function, one x value has one and only one y value. So, and then D goes to 4, but it does not matter since one x value has two y values. This is not a function. It does not represent a function. Okay. Now, how can you determine if an equation is a function? What are some key things to look for? So the next three examples, we want to know, are these equations actual functions? So first one we look at is y equals 2x minus 5. All right. So remember, to be a function, 1x has one y. So one giveaway could be the exponents. So, and when I say exponents, I mean just look at the y, the exponent on y. So this y value, or variable, has an exponent of 1. This x variable has an exponent of 1, which means that if I plug in one x value, I'm only going to get one y value out of it. So degrees, looking at exponents, looking at degrees, can tell you whether an equation is a function. And this one is a function because you get one x and one y, which is in the definition. So that's one way to look at it. You can look at the exponent or degree of y. It doesn't matter the degree of x. We can put whatever we want in as long as there's one input and one output. That's what we're looking for. Okay. So we've looked at the exponent and degree and have verified, yes, this is a function. Another way to look at it is to make an XY chart. And just a simple XY chart. Let's see. -1, 0, 1. If I take these x values and plug them in, I should only get one output of y. So if I plug in -1, that becomes -2 minus 5, which will give me -7. If I plug in 0, I'll get -5. And if I plug in 1, I'll get -3. Now, what we see is that for every x value, we have exactly one y value. -1 goes to -7, 0 goes to -5, 1 goes to -3. Okay. And then the third way of checking is, well, graph it. If you were to graph this function, I'm just going to do a sketch. Your function would start at -5, and then our slope is positive, so it would go like this. And graphing it to show that it is a function means that it shows that every x does have a y value. So let's say I had an x value here, and I go up. There would only be one y value there. And that would go for the whole graph. So for every x, there's one y. For every x, there's one y. So y equals 2x minus 5 is definitely a function. Okay. So we have a function. Y equals 2x minus 5 is a function. And of course, you see the easiest method of checking is look at the exponents. That is the easiest way to check. So let's go to number 2. We want to know, is x squared plus y squared equal to 1 a function? Well, what did I tell you? Look at your exponents. The exponent on x, I said, doesn't matter. We only look at the exponent of y. And that is 2. So that means if I plug one x value in, I'm going to get 2 y values. So we can say A, y has exponent or degree of 2, which means not a function. But again, to show you, instead of making an XY chart, let's find another method. Let's say solve for y. So if we solve this equation for y, I'm going to subtract x squared over to the right side. And then I'm going to square root both sides. We will end up with y equal to plus or minus the square root of x, negative x squared plus 1. Which means, once again, if I plug in one x value, I'm going to get 2 y values, which means it is not a function. So this is still not a function. And then, even if you created an XY chart, let's plug in, what could I plug in? I think I could plug in -1, 0, 1. Let's see. If I plug in -1, 0, 1, if I say -1 squared, that's 1, but you get -1, you'll get 0. Plus or minus 0 doesn't count. But then I plug in 0, and I'll get the square root of 1. So I'll get plus or minus 1. And then if I plug in 1 again, I'll get 0 again. Okay, so what we see here is that for one x value, I get 2 y values. So again, not a function. All right. And then if you were to graph it, well, guess what x squared plus y squared equals 1 is? It's the graph of a circle. So this means that for one x value, if I go up, I have one y value there, and another y value there. So once again, not a function. All right. Perfect. So we see all the methods to determine whether something's a function or not. It seems like looking at the degree is the easiest. So let's go ahead and just apply that to number 3. Now that we know, right? We know everything. So A, let's look at the exponents. Again, the x's don't matter. It doesn't matter if there's 2 x's here. When you plug in for x, that counts as one input, right? And for that one input of x, you're going to get one output of y. So y has exponents or degree of 1, which means we have a function. All right, and that's perfect. Let's see, we don't have to solve for y. We could make an XY chart and all that lovely stuff, but let's just go and graph it. And we'll be graphing functions like these later on in the semester, so I'll show you what this graph looks like. You'll have something called a vertical asymptote at -2. You'll have something called a horizontal asymptote at 3. And our graph would look something like this. Let's see, if I plugged in -3, that would be -9 minus 10 and over negative, so you have something that looks like that. And once again, for every x, there's one y. So this is definitely a function. Okay, so that is the definition of a function, right? For a equation or an XY chart or a set of numbers to be a function, every x must have a y, right? But an x cannot have 2 y's. That is not a function. All right, finding values of a function. So this is essentially evaluating a function. So functions can be denoted such as by letters such as little f, capital F, lowercase g, capital G, etc., etc. So you can name the function whatever you want, whatever letter you want to choose. If f is a function, then for each number x in its domain, the corresponding image in the range is designated by the symbol f of x or f at x. Remember that x is the independent variable and y is the dependent variable. So remember, y always depends on the input of x. Okay, so we are given a function here, 2x squared minus 3x, and we want to evaluate it. To evaluate a function is simply to substitute that value given in for every x, and then you will simplify. That's how you evaluate. You substitute and then simplify. So let's try it out. So we're going to take this 3 and plug it into every x into this function. Oops. Go back. There we go. All right, so that's simple enough to say 2 times 3 squared minus 3 times 3. We have now substituted. So then we will now simplify. 3 squared is 9. 3 times 3 is 9 with a negative in front. Then you'll get 18 minus 9, which will give us 9. Okay. So what we're also saying here is that when x is exactly 3, the values of y, so the value of f at 3, the value of the function at this x value of 3, is 9. That's all we're saying. It is important to know how to read function notation. All right, again. Now this operation says just take 3 and multiply the function by it. So 3 times f of x. So we'll put a 3 out front. I'll put parentheses, and then I'll put our function inside, because it's 3 times f of x. 3 times 2x squared minus 3x. Distribute the 3, and we're done. Six x squared minus 9x. Done. Remember, substitute, simplify. That's it. The word missing here is solve. We are not solving anything. We are just evaluating, substituting, simplifying. Okay, the next one says take negative x and plug it in for every x into the same exact function. So we'll have 2 times negative x squared minus 3 times negative x. Okay, so this becomes 2, and negative x squared means negative x times negative x, right? So this means negative x times negative x, which will give me positive x squared, right? So I'm back to where I was. I'm back at 2x squared, but then the negative 3 and the negative x make positive 3x. Excellent. All right. And last one. Negative f of x. It's just like the second one. Take negative 1 and multiply it by the original function. Negative 1 times 2x squared minus 3x. Distribute that negative 1, and we're done. And there we go. That is how you evaluate a function. Evaluate means to substitute and simplify. There is no solve. Okay. Okay, the next one builds on evaluating, substituting, and simplifying. But this one is so much fun. It's called the difference quotient function. And this utilizes tons and tons and tons of algebra, okay? You will be foiling, distributing, canceling like terms, combining like terms, factoring, and canceling out again. It involves a lot of work. You will see the difference quotient again in pre-cal, probably just as a review, but then you will see the difference quotient big time when you get to calculus. The difference quotient is makes up part of the definition of the derivative. And if you're wondering what the derivative is, it is just a fancy word for slope. So the derivative can find the slope of any function at any given value of x, but that's not till you get to calculus. So for now, we do the difference quotient. We do the struggle through all this algebra. So when we get to calculus, we can do these blindfolded, no problem, no issue. So let's get through the algebra parts. Okay, so the difference quotient is given as f of x plus h minus f of x over h. So the way I show it is step by step by step. And if you don't want to do it step by step by step, that is definitely fine. But I say do it step by step, watch everything, watch your signs. So let's get started. Okay, so the way I like to do the difference quotient is I always start with the first piece. I always start with f of x plus h. What is f of x plus h? So we'll call this A. This means take x plus h and plug it in for every x into this function. That's what we're going to do. So, and it's again, evaluate, substitute, simplify. So we have 2 times x plus h squared minus 3 times x plus h. And now the simplifying part. X plus h squared means we have 2 of those. So now we have 2 times x plus h, x plus h. Go ahead and distribute that -3 already. -3x minus 3h. And now we must FOIL these 2 guys. Don't forget the 2 outside. 2 times, and when you FOIL this, you're going to get x squared plus xh plus, so I'll write it down, plus xh plus hx, which are the exact same thing. Since these 2 are the same, just go ahead and combine them already. Which means if we combine them, we're going to get 2hx or 2xh. It doesn't matter. You can interchange them if you want. I was just being in alphabetical order. Okay, and then h times h, h squared. All right, step 1's almost done. Distribute that 2. 2x squared plus 4hx plus 2h squared minus 3x minus 3h. And guess what? Step 1 is done. Nothing ever cancels or combines on step 1. Okay. Now, on to step 2, or step B. Now, what I like to do is take the whole numerator and put it together. So we're going to have f of x plus h minus f of x, and put those together. So that's the second step. So B, f of x plus h minus f of x. Okay, so now we are going to write whatever we found above in step A. Yes, we write it all over again. 2x squared plus 4hx plus 2h squared minus 3x minus 3h. So all of this is f of x plus h. And now we subtract f of x. We subtract the original function 2x squared minus 3x. And before you put that function in, there is something really important you need to put before that. And those are parentheses. If you forget your parentheses when you plug this function in, you are going to get this wrong, and all this hard work goes out the window. Parentheses, parentheses, parentheses. All right. So we put it in, 2x squared minus 3x, close parentheses. And there's f of x. Good. Now, distribute that negative, and a bunch of canceling is about to happen. So again, unfortunately, rewrite it. Distribute that negative. And now let's start to cancel some terms. Start looking for the like terms. 2x squared, negative 2x squared, gone, gone. Negative 3x, positive 3x, gone and gone. All right. Now what we are left with, because nothing else is going to cancel, is 4hx plus 2h squared minus 3h. This is all that's left over from step 2. Okay, so in my math lab, I think it wants this answer. So this could be like the my math lab answer. But then what you can also do on step 2, what I like to do is take out a common factor. And that common factor all the time is h. So for these notes, let's go ahead and factor out h, because if we factor out the h, it's going to make the last step a lot easier. So take the h out, and we're left with 4x plus 2h minus 3. And that ends step 2, or step B as I have it. All right, that's because we factor it out. I think my math lab says don't factor the h out. I don't know why. Oh, I ran into that. Okay, we'll have room, don't worry. So then we run into step C. I thought I was writing small too. All right. And step C is putting the whole thing together. So it takes f of x plus h minus f of x, and we put it all over h. So basically, you take whatever we found in step B, rewrite it, h times 4x plus 2h minus 3, and you put it all over h. And look at what magic happens here. This h, gone, gone, and we are finished. And there it is. This would give us the derivative of the original function, meaning we could find the slope at any given point or value of x. But again, we don't worry about that right now. We just worry about all the heavy algebra. Okay. And that's the difference quotient. So we'll start number 2. But let me erase this and just let you know that when you work these different quotients, your goal, your main goal in life with these different quotients, get rid of that h. That's your job. Get rid of that h. And we did that on the last one. Ooh, mind the crazy hair. Since we are remote and don't go back to campus till next August, I'm not gonna get my hair cut till next August. Ooh la la. We'll see. I might get annoyed with it. All right, back on topic. All right. Let me make a little boundary for this. All right. All right, I'll start on the left side this time. And now we have 4 over x squared. So we're going to do the exact same steps. So a f of x plus h, and it was 4 over x squared. So we're going to get 4 over x plus h squared. And guess what? That's it. Don't do anything else. If you're wondering why I'm not foiling that out, is because there is never, ever, 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 ever a need to FOIL out your denominator unless I tell you to do so. Never FOIL your denominator. You make more work for yourself. Okay. And since we can't do anything else, we move on to step B. Lovely. So we say f of x plus h minus f of x. So we take 4 over x plus h squared, and we subtract the original function. Put your parentheses, 4 over x squared. Okay, well, all of this is purely algebraic. So our job is to put these two fractions together. And if we want to put these two fractions together, we need a common denominator. And just to let you know, these have nothing in common. So since they have nothing in common, all we do is that lovely, what was it back then? Cross, smile method, right? So cross, smile, right? Which means I'm gonna take this fraction and multiply it by that denominator. So I'll have x squared over x squared, and then this fraction multiplied by x plus h squared over x plus h squared. There we go. That's common denominators. Okay, and now we get 4x squared minus 4 times x plus h squared all over the same denominator of x squared times x plus h squared. Okay, and all we have to do now is clean up the numerator. Now look at this interesting piece. We've done this already. We have foiled that out already. And this is something that you're going to see common in all these different quotient functions, is this x plus h squared. So if you ever see that, just know that it will always foil. Oops. Well, it'll expand to this, but it will always foil to that. Always, no matter what. So just keep that in mind. It will save you time. That was not a rhyme, or was it? Okay, so we'll get 4x squared minus 4 times, and like I said, we're saving time. We're putting in the foiled out version. X squared plus 2hx plus h squared, all over the same denominator. Now, distribute that -4. Don't forget to bring that negative as well. That negative goes to all the terms. Over the same denominator. And after all this lovely work, those two terms are the only ones that cancel. So what we are left with is -8hx minus 4h squared over x squared times x plus h squared. All right, and like I said, this answer would probably be great for my math lab because they don't want you to factor out the h. But we can always end it by taking out the h. All I want is a common factor of h. Yes, I see 8 and 4, and if you thought you can take out a 4h, a -4h, you are absolutely correct. But there is no need to. We're just going to take out an h. And that'll leave me with -8x minus 4h over x squared times x plus h squared. Step 2, done. Whew. All right. And then C. Let's finish it up. Take everything we found at the end. Take everything we found at the end of step 2 and put it all over h. Put it all over h. And what you see here is that, let's see. Do I have room? I have room. I'll just write it a little smaller. There we go. And I won't make this as big. So what we do is we take this h and we put it over 1 and multiply by the reciprocal. So you'll have h times -8x minus 4h over x squared times x plus h squared times 1 over h. We multiply by this one's reciprocal, and this h and that h, gone, gone. And we get our final answer of negative 8x minus 4h over x squared times x plus h squared. And there it is. Fractions, eat your heart out. Okay, excellent. Let's keep moving. All right, next is domain of a function. So in order to find the domain of a function, you have to know what type of function we are dealing with. So knowing the category, knowing the type of function is essential to find its domain. So number one, we have f of x equals x squared plus 5x. This is called a polynomial function. And we've talked about polynomials before. We've mentioned it in class. What does it mean to be a polynomial? To be a polynomial means your degrees are whole positive numbers. They are called positive integers. And since this is a polynomial, the domain for all polynomials will always be all real numbers, negative infinity to infinity. As long as it's a polynomial, this will always be its domain. That's it. That's simple. Okay, next. 2. G of x equals 3x over x squared minus 4. This is a fraction, or what we like to call a rational function. This is a fancy word for fraction. So, if you're ever given a rational function, to find its domain, you take whatever's in the denominator and set it equal to 0 and solve for x. This will help show us what numbers we need to avoid so we don't plug them in and get undefined or get an error on our function. So this is how you find the domain of a rational function. So we solve for x here. I'll just move the 4 over. You'll get x squared equals 4. Square root both sides. And we'll get x, x equals plus or minus 2. Do not forget it's plus or minus when you do the square root method. Okay, but the question is, can we actually be equal to these values? And that answer is no. If I plug in positive or negative 2 into this function, we are always going to get 0 in the denominator. So the way we will state our domain is that x cannot equal plus or minus 2. All right. But of course, we want the important notation, the interval notation. The interval notation representing this domain. So what our domain above says, our shorthand notation, set notation says is that we can be any number we want except for negative 2 and positive 2. So any number we want except for -2 and +2. So to represent that in interval notation, we will start at -infinity. We will come up the number line and stop at -2. And then we will union the next sets of numbers. We'll start at -2 and end at 2. And then we union the last set of numbers and start at 2 and head towards infinity. So this interval notation shows us where this function exists. At what numbers can this function exist? This function exists from -infinity to -2, in between -2 and 2, and from 2 to infinity. All right, so that's how you find the domain of a rational function. Okay, next is something we've seen before. This is the square root function, or we can say this is an even root function. So to find the domain of an even root function, we take whatever's inside the house and set it greater than or equal to 0. Because what do we know about square roots? We can't have anything negative inside. So that is hence the greater than. Can we have 0 inside a square root? And that answer is yes. You can take the square root of 0. So that's why we set it greater than or equal to 0. All right, and now all you have to do is solve for x. So move the 4 over, and you'll have -3x greater than or equal to -4. Or you could have moved the 3x over, it doesn't matter. You'll get the same answer. And then you divide by -3. And remember, when you multiply or divide on an inequality, the inequality will always flip. So we are left with x is less than or equal to +4/3. Okay, so that's your set notation. We want interval notation. So what this inequality is telling us is that we must choose x values less than or equal to 4/3. So we have to choose numbers smaller than 4/3. So if we're going less than 4/3, we are headed towards -infinity. And as we come up the number line, we stop at 4/3. And bracket because it's included. Okay, and that's what we do for an even root function. All right. Last one for domain. We have 2 over the square root of x minus 1. This is a rational with even root. So, to find the domain of this, oops, we'll take whatever's inside the house, x minus 1, oops, and this time, it's going to be a little bit different from the one above it. We are only going to set it, set it greater than 0. We only set it greater than 0. Why can't we set it greater than or equal to 0 like the one above it? And the reason is this radical is in the denominator. And what number can never be in the denominator? 0. So that's why we can never set it greater than or equal to 0 when it's in the denominator. only. So this will only be a greater than. Add the 1 over. Your set notation is done. And now you want your interval notation. We want numbers bigger than 1. So this means we're going to start at 1. And head towards infinity. And there's our answers. And that is domain. I'm sure you've seen some of this before. Okay. Last one, and we're done. All right, this is just operations on a function. We want to show that we can add 2 functions, subtract 2 functions, multiply 2 functions, divide 2 functions, and at the same time, find their domain. So it wants us to do the operation and find the domain, but before we start, we should actually find the domain of both functions first. So let's look at f and g. And they're both rational functions. So this means that the domain of f is going to be x can't equal -2. And the domain of g is going to be x can't equal 1. All right, because we set the denominator is equal to 0 and solve for x. All right. Now, put it together. And the sum, meaning it wants what is f of x plus g of x. That's what it wants. So that's as simple as substituting in the functions. 1 over x plus 2. That's f of x plus g of x, x over x minus 1. Okay. And now we want to simplify more. So in order to put these 2 functions together, we need a common denominator, which means these have nothing in common. So all we're going to do is multiply them by their own denominators, or by the other's denominator. So this means that x over x minus 1 will be multiplied by x plus 2 over x plus 2. And 1 over x plus 2 is going to be multiplied by x minus 1 over x minus 1. And let's keep simplifying. We will end up with x minus 1 plus x times x plus 2 over the same denominator of x minus 1 times x plus 2. And now simplify some more. Distribute that x, and x minus 1 plus x squared plus 2x over x minus 1 times x plus 2. Keep going. Highest power first. We'll get x squared plus 3x minus 1 over x minus 1 times x plus 2. And that one is done. Okay. And then it said find the domain of your finished product or finished sum, right? So our domain for this one, if you look at both denominators, is going to be the same as the domains above that we found for both functions. X can't equal 1 and x can't equal -2. All right, and we'll just leave it as shorthand set notation. If you want interval notation, then you know how to do it now, right? Okay. So now this one wants the difference. So this one wants f of x minus g of x, which means, again, you'll do 1 over x plus 2. Now you'll do minus x over x minus 1. And since we did the common denominators above, it's going to be the same exact thing as this step in the sum version. So all you have to do is change this plus sign to a minus. But again, I could write it in times x plus 2 over x plus 2, x minus 1 over x minus 1. And we have x minus 1 minus x times x plus 2 over the same denominator of x minus 1 times x plus 2. Distribute x minus 1 minus x squared minus 2x over x minus 1 times x plus 2. And simplify, writing too big again, sorry. And you'll be left with negative x squared. What do we have? Minus x minus 1 over x minus 1 times x plus 2. Okay, where, again, the domain is the same. X cannot equal 1. X cannot equal negative 2. All right. So that was addition, difference, finding the domain, and now we have the faster ones, product and quotient. So product says f of x times g of x. So we just take our f of x, 1 over x plus 2, times g of x, x over x minus 1. And these are a lot faster because when you multiply fractions, you do not need a common denominator. You just multiply straight across. And we will get x over x plus 2 times x minus 1. And look at that. That one's done with the same domain. X cannot equal negative 2, and x cannot equal 1. All right. Next one's fast as well. So you'll get f of x over g of x for the quotient, and we'll have 1 over x plus 2 over, right, am I writing these right? Over x minus 1. And now you have fraction over a fraction. You have fraction cake, and the only way to get rid of fraction cake is to multiply by the reciprocal. So we reciprocate the denominator, or like students love to say, we flip. So 1 over x plus 2 times the reciprocal, x minus 1 over x. And once again, no common denominator needed. And we are left with x minus 1 over x times x plus 2. Okay, but now our denominator has, or our domain, well, our denominator definitely has changed, and our domain is going to have an addition. Okay. So two things will stay the same. So this is going to have the same domain as the last three problems. X can equal 1. X can equal -2. And now we have a new addition. New addition. Yeah. You have this X, and this X cannot equal 0. That's it. We now have 3 parts in this domain. And that's it, guys. Right? Didn't lie. That was the very last one. So that is functions, what a function is, finding the domain of a function, performing operations on functions, the difference quotient, that's a beast in itself. Watch every single step that you do. Don't mess up a minus sign. Evaluating a function, remember evaluate, substitute, simplify. No solve. And determining what a function is. Okay, that's it. See you on the next one.